Welcome again for this time to our class of chemistry practical. Today we continue with chemistry experimental questions with their solutions. Other students, be aware in this class to understand how the experiments have been solved. Remember that our specific objective is determination of atomic mass of a known element. So for this session, we look and we will discuss the experiment number 2. Experiment number 2, you are provided with the following solutions. Solution A, made by dissolving 2.45 grams of sulfuric acid dissolved in half liter of the solution. Solution F contained monovalent metal M hydroxide, which was made by dissolving 2 grams of metal hydroxide in a liter of distilled water. In that case, according to our solution F, we are required to determine the metal M and to identify the name of that element in that compound of metal hydroxide. Our indicator is methyl orange. Procedure: titrate the acid against the base by using 2 drops of your indicator, which is methyl orange, and then obtain 3 titer values of burette readings. Remember that our solutions E and F, solution E is acid and the solution F is base. So you titrate the acid solution E against the base solution F by using 2 drops of your indicator methyl orange to get the theta values. Questions: after seeing the procedure, performing titration. That is the questions we are supposed to solve systematically, step by step, in order to understand our experimental question. Question: what is the color change is observed when methyl orange is added to a solution containing monovalent metal M? That solution is solution F, which is base solution or alkyl solution. Another question: write a balanced chemical equation for the reaction between solution E and the solution F. Solution E is sulfuric acid, contains sulfuric acid, and the solution F contains base, which is unknown, M hydroxide. Another question: what is the volume of acid required to neutralize the volume of base? So here we determine the amount of acid, volume of acid required to neutralize the required volume of base for the reaction completion, or for the reaction. That is the question. Another question which is very important to you as a student, take a note very careful, showing your procedure clearly. Identify metal M in metal M hydroxide. So this question you are supposed to understand in order to know where you are going to start and then where you are going to be the end of your solution of your calculations, to be sure you understand the format of these questions, even if you are going to meet with another questions which we have had the same with this question. Another question: state NFO real life application of this in practical. That is our questions. I think you see the questions, and now we are together. Let's check the solutions and the answers for those questions asked in our experiment. After looking those questions, solutions, remember that before recording the table, make sure you show the pipette used and the burette used. According to our question, pipette used is 25 mils and the burette used is 50 mils centimeter cube. The answer for the color change according to our indicator was methyl orange. the color change was from yellow to orange. Balanced chemical equation. Sulfuric acid react with metal hydroxide. The product is metal sulfate plus water, and that the balanced chemical equation there is 1 mole of sulfuric acid reacted with 2 mole of metal hydroxide, which is base. So the molar ratio is 1 mole of acid and the number of mole of base is 2. Table of results. By considering the SI units and the 2 decimal places of the values, you are supposed to record a table of results of Molarity readings as you see there. After recording and filling the value in table by considering the SI unit and the 2 decimal places, remember to calculate the average volume used even if you are not asked to calculate in your questions. That is very important. The average volume used is calculated by this formula: volume 1 from the table, volume plus volume 2 plus volume 3 divided by 3. According to our solution, our titration results, the volume used is 12.5 plus 12.4 plus 12.6 divided by 3. Our total value 37.5 divided by 3. The volume of solution, the volume of the used of solution E, which is acid, was 12.5, and that is the volume used for titration to neutralize 25 of volume of base for the reaction to be complete or to reach at the ending point. The volume of acid required to neutralize the volume of base, 12.5 mils of acid required to neutralize 25 mils of base for completion of the reaction. That is our solution of that question. The question, which is very important, by showing you a clear procedure to calculate the metal M, let's check the procedure or solutions to see how these questions have been solved. First procedure, according to the question, guided you as the student to show the procedure one by one until the end of the solution in order to find the metal M, to identify metal M. The first procedure is to determine the molarity of acid. Because our question guided inside of base, so we are supposed to start with the molarity of acid. Molarity of acid, according to our data, is the concentration of a molar mass. Sulfuric acid, that is acid provided, and is very open, we can get the molar mass. Concentration, we have mass and we have the volume. So the concentration is mass over volume. So according to the data, concentration is 4.9 gram per decimeter cube, and the molar mass of sulfuric acid is 99 gram per mole. So molarity of the solution E, which is acid, molarity of acid is 4.9 divided by molar mass 98 gram per mole. The answer of that molarity is 0.05. So the molarity of the acid solution is 0.05. That is the first procedure. Second procedure, after determining the molarity of acid, now we are going to determine the molarity of base solution. Because metal M is unknown, we use molar ratio to identify the molarity of base. Molarity of acid is 0.05, volume of acid is 12.5, molarity of base is required, volume of base is 25, number of mole of acid is 1 mole, number of mole of base is 2 mole. So molarity of base is molarity of acid times volume of acid times number of base divided by volume of base, in that case times the number of mole of acid. Mole per dm, molarity of acid times volume of acid 12.5 times 2 mole of number of mole of acid divided by volume of base, which is 25 times 1 mole of acid. The value of molarity of base is 0.05 mole per decimeter cube. That is procedure number 2. After determining the molarity of base, procedure number 3 is to determine the molar mass of metal hydroxide, of M hydroxide. Molar mass is the concentration over molarity. Concentration in gram per decimeter cube. Molarity is mole per decimeter cube. The concentration is the mass over volume. According to our data, we have dissolved the 2 grams in a liter. So the mass is 2 grams and the volume is 1 decimeter cube, 1 liter. So the concentration of base is 2 grams per decimeter cube. So the molar mass of metal hydroxide is 2 grams per decimeter cube over 0.05 mole per decimeter cube. So the molar mass is 40 grams. Procedure number 4 is to determine the atomic mass of metal M in metal hydroxide. After getting molar mass, that is, we can get relative atomic mass. The difference of relative atomic mass and molar mass has a SI unit of the same value. Relative atomic mass, there is no SI unit. So we take that molar mass, we remove SI unit to get the relative atomic mass of that metal hydroxide. Procedure number 4 is to determine the atomic mass of metal hydroxide. To get the value of metal hydroxide is to take relative atomic mass from the molar mass, which is 40, minus the atomic mass of oxygen 16 plus hydrogen, atomic mass of hydrogen, which is 1. The total is 17. So we take 40 minus 17. The rest is 23. According to that value, 23 represents the atomic mass of sodium. So the atomic mass of M is sodium. Let's see the following, the application of this practical. This practical deals in volumetric analysis. That means it's based on determination of the active volume and the concentration of the solution. Due to that, this practical is applied in the following fields or different areas in daily life. The first application is applied in water authorities to determine the amount of salt in water. B is applied in medicine to determine the concentration of viruses or bacteria in the blood samples, and then to apply to determine the amount of salt in urine. Applied in medicine to determine the amount of antacid tablet that can neutralize the stomach acid. Another application applied in agriculture to find the composition of different substances in a soil solution, and then is applied in industries to determine the acidity of fruit juices, and the vinegar also to determine the percentage purities of various chemicals manufactured in industry. According to that, as a student, I am sure you have understood this lesson we have discussed here. Let's check. You can pass through to cross-check step by step, question by question to understand more. Be together here, still learning with me for the coming lesson. Thank you more.